Hi, everyone. Wow, you showed up for the optional lesson. Ah, that's great. You must like math. So here we go. We're going to look at how to work in radians. And basically, like, how do we convert from degrees to radians? Because we've spent all this time learning degrees. Now we're going to learn radians. First off, let's take a look at the unit circle again. We're back here. So what is the circumference of this circle? Well, we know that the circumference of a circle is given by this formula here. The circumference is equal to 2 times pi times r. But here the r is 1. So the circumference is just equal to 2 pi. Okay, it takes 2 pi to go all the way around. So the circumference here is 2 multiplied by pi. Now, how many degrees is that? Well, we know that that's 360 degrees. Okay, there you go. Lesson done. 2 pi means 360 degrees. When we're measuring angles, this is the angle 45 degrees. But we could also express that in terms of radians, in terms of how far have we gone around the circle by the time we get there. Okay, and well, if I went there and then I did it again, so that's 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, then I would get this angle. So this must be pi over 4, because pi over 4 would be 8 times smaller than this. Okay, so let's take a look and we'll step back a little second. 360 degrees, well, that would be going all the way around. We've traveled the entire distance. Okay, so 360 degrees is equal to 2 pi. Okay, this is degrees, this is radians. Now let's take a look at some key angles in radians. And we might work backwards here to get to these smaller ones that we're particularly interested in. So let's take a look first at, 360. We already know that that's equal to 2 pi. All right, what about 180? Well, 180, let's do this one. It's a very key one. If we go around a circle, well, that's 180 degrees. That's half a circle, so it must be half of that. So half of 2 is just 1. So this is just equal to pi. 180 equals pi. Okay? And let's take a look at some other key ones. 90 degrees, for example. 90 degrees would be half of 180. So 90 degrees would be pi over 2. All right? Now, we can get 45 degrees from that because it's half of 90. So half of a half is a quarter. So let's put that one on. So this is 45 degrees here. And I'm going to stop drawing these little circles going around. I think you get the idea. The distance here would be pi over 4. All right. And then 270, well, that would be 180 plus 90. So pi plus pi over 2. So that would be equal to 3 pi over 2. Okay, that's 1.5 pi. Okay, now let's take a look at 60 and 30, see if we can figure out those. 30 degrees, if I multiplied that by 3, would give me 90 degrees. So if I divide that by 3, I'll get 30 degrees. So that one is going to be here, pi over 6. And 60 degrees here, so there's my 60-degree angle. That would be pi over 3. Double this one. 2 pi over 6, pi over 3. Okay. So there's some of our key angles in degrees and radians. Now you know why your calculator does weird stuff if you don't tell it, work in degrees, please, don't work in radians. Later on, you'll probably get more comfortable working in radians than you do in degrees as you go to advanced levels in mathematics. Okay, and also let's just take a look at something in Desmos here. Turning off radians and degrees is a little bit like doing a K transformation, because it multiplies your input. Okay, so let's graph a y equals sine x, and we'll notice, oh, we already see a nice squiggle there, right? Because it's working in degrees. Okay, so here's a full revolution, 2 pi, 0. Here it is 180, or pi. Here it is pi over 2, 90 degrees. Okay, so that's why. we're seeing that when we're in radians. Isn't that nice? Now let's flip it back to degrees. It's been stretched. It's been stretched by a big factor k, because now all our inputs are being divided by 360 and multiplied by pi over 2. Okay, so you see I need to see all the way to 360 to see one cycle. So that's why these things are happening, and the difference between degrees and radians. Okay, thanks very much for showing up for your learning, everyone, and bye for now.